In this lesson, I'll show you 3 examples on how to solve problems involving density. Let's start with question number 1. The question reads, calculate the density of nitrogen gas at 125 Celsius and a pressure of 755 millimeters of mercury. I'm going to start by writing out everything that I've been told. I've been told the temperature, which is 125, and I'll represent that by the letter T. I need to change this into Kelvin, so I'll put an arrow with a K. Furthermore, I've been told the pressure, and the pressure will be shown with a P, and that's at 755 mmHg, which I need to convert into atmosphere. According to the density formula, we can find density by multiplying the pressure with m, which is the molar mass, and the molar mass of nitrogen is 14.0067. Nitrogen gas has the molecular formula of N2. So I'll take this number, multiply it by 2, and that will give me capital M, molar mass. Let's go ahead and do that. We have 14.0067 times 2 grams per mole. What else do we need? We need to know what R is, and that's a gas constant. The gas constant is equal to 0.082057. And it has the units liters times atmosphere over moles times the temperature in Kelvin. And we know what T is, it's stated right there. Now before we can find out what D is equal to, even though we have all the information that we need, is that 755 needs to be converted into atmosphere. And the conversion ratio is 1 atmosphere is equal to 1 torr, or 760 mmHg. So if I take my number of 755 mmHg and multiply it by 1 atmosphere over 760 mmHg, this unit and this unit will cancel out, and we can use our calculator. 755 divided by 760. This gives us 0.9934. Since this has 3 significant figures, we should also stop at 3, although I'll continue to write more just to prevent any rounding errors later on. So I'll write down 0.99342. Now we can finally input all of this information into the formula, where we have density is equal to the pressure that we just found, multiply to the molar mass, which we also found to be 14.0067 times 2. Let's do that calculation. 14.0067 times 2 gives us approximately 28.013. 28.013, all divided by our constant, which is written right here, times the temperature. Let's write that down. 0.082057 multiply to the temperature of 125 plus 273.15. That's the conversion from Celsius to Kelvin. You take your Celsius and you add it to 273.15. Let's go ahead and figure this out, starting with the numerator, the top part of this fraction. 0.99342 times 28.013, we just found the top, divided by 0.082057 times, and I'll put this in brackets just so that my calculator doesn't get confused as to what it is I'm doing, 273.15, and I end up with a density of 0.85179. Density is equal to 0.85179, and the units of density in our case are in grams per liter. And if you actually wrote down all the units as you were doing your calculation, you would find out that you would end up with your grams over your liters. Now, we had 3 significant figures in this number and this number. We should also end with 3. That being said, everything after this 1 is insignificant, although this 7 is greater than 5. So this 1 will become 2. We have density is equal to 0.852 G over L. Now, if you would like to see the answers to questions 2 and 3, make sure you watch part 2 of this video where we tackle those 2 questions. We'll see you soon.